Hey team, it's Mr. Z, and today we're going to kind of talk about the general gist between odd and even rational functions. Let's take a closer look. So, before I get started, I just want you to start off by thinking of the rational function that we've been talking about, 1 over x. Now, 1 over x does resemble an odd function because it has an invisible exponent of a 1, and we know this graph from doing it multiple times that it has an asymptote at x equals 0 and y equals 0, and this frames the graph to look like so. Our second one is 1 over x squared, and the difference between these two is the range. Basically, if I plug in a negative number, if I plug in negative 1 squared, that's going to be a positive 1. If I plug in negative 2 squared, that's going to be a positive 4, which basically means the y values, the outputs, cannot be negative, leading us to the following graph. Boom. Both of these can be reflected if need be, but let's take a look. So this first one is the range is all real numbers excluding 0. Remember, range is a scan from bottom to top, and it includes all real numbers including zeros. This is only going to be odd. The even does not include negatives. That is the reason that it is only odd. Now, the graph could be in any quadrant. Looking at it, you can go ahead and see that it's going to be the odd. If I reflect it, it's going to be, it could be in either one. You could also make the argument that if you reflect an even, it can be there as well. Next up, the domain is all real numbers excluding 0. Domain is all real numbers. Well, they're negatives. If I look at my scan, boom, 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 going left to right, it only skips 0. It only skips 0. Therefore, it can be both. The graph only exists in the first and second quadrant. This is going to be even. And FYI, it goes 1, 2, 3, and 4. A horizontal at x equals 0, well, both of them can be odd or even. And then finally, the range is all real numbers greater than 0, aka no negatives, and this is only going to be even. Hope this review helped, team. That's it for now. Ciao.